Assalamualaikum everybody. I hope you all are doing well. So this is officially the last class of our May-June 2026 demo class series. And inshallah from Monday onwards, we're going to be having the classes only for the registered kiddos. So I hope this is a good end to our free demo class this week's whatever demo class period or the whole week. And so inshallah in today's class, we're going to be starting off with the same hexadecimal concept which we were doing last night. And we were discussing its uses and उसी तरीके से we're going to continue जो एक आध use हमारी रह गई थी we're going to cover up that initially and then afterwards we would be doing just a minute, let me open up one document and then we can start off. See, so yeah, so we're going to be starting off with what do we call it, the concept which we were left with last night, the uses of hexadecimal. We're then going to be shifting towards one other concept of logical shifts and would finally be ending the class with the learning addition of binary inshallah. So I'm just starting my screen sharing. Can anybody of you kindly confirm if they can see the screen clearly? And also, is my audio clearly audible? Yes or no? Okay. You all should be visible. The screen should be visible to all of you by now. All right. So perfect. Acha, then let's start off with where we left. Acha, guys. So the last thing we studied last night was that we understood what hexadecimal and all that stuff is, and we were basically looking into the uses of hexadecimal, right? So we study what's error codes, what IP addresses are, what MAC addresses is, and like all the basic identification of where a hexadecimal is used within those concepts, right? So the details of what MAC addresses, what IP addresses, or all these stuffs would be inshallah later on covered up in their respective topics. But for now, in chapter number 1, the sole purpose of identifying these things is just to let you all know that we are going to be making use of hexadecimal in this specific place. So we were just left with one part, and inshallah we're going to cover up that today, and that is basically HTML color code. Say HTML ML color codes. So I'm not sure if anybody of you have ever explored web programming, or maybe is someone into graphic designing. But if you are someone into graphic design or have done web development, you might have seen something like this hashtag 77AA88. And this could be either used to represent a specific color, or maybe if you're making use of it in a web development, then you might have seen this as a code while writing the program. If you, let's say, wanted your screen or background to be of a specific color, you might have done it this way. So let me give you guys, if I can open Canva up here. Canva is like a graphic designing tool. So let me show you guys what I mean by this thingy. But whenever you're trying to represent colors in computers, because we have a lot of combinations, possible combinations, we could sort of let's see, do we have a post up here? Let me just take up one post. So yeah, let's just look into this. So this is the yeah. Oh, do we have it in good notes? Okay, let me see. Yep, good one, by the way. Let me, oh no, yeah. Yeah. Thank you so much. Thank you so much, Samrat. That's great to know. So yes, we do have hexadecimal uses up here too. So if I come up here, you see I can select any one color. But then at this point, you might see HEX hexadecimal and EAFFB6. This is sort of a unique identification code. And I can sort of select any color. Now, why do we have this 27255D or these digits? And what are these digits? These are basically hexadecimal values, which are basically introduced for the purpose that if we want to represent, because we know that we have multiple sort of shades existing out here, right? We have multiple sort of shades, maybe a dark green or like apple green, or maybe like, I remember back then when I was preparing for my IGCSE first language English, we had this descriptive writing part where I had to like literally memorize the different shades of a specific color. So all these colors have a lot of shades, and so to represent all of them and to indicate the computer and tell them that we are representing a specific color, what computer programmers did was that they came up with the concept of color codes. And so when writing HTML programming language, or wherever, like if you're using some graphic designing tool, the color codes, which are like 778888, these are basically sort of also written in hexadecimal. So you guys should be full aware. Yes, I have done descriptive writing. So this is one point you all should be aware of. कि यार आपके जो color codes है, those are also represented in hexadecimal, and these basically represent different sort of colors. So like if I want to alter this part and make it something like maybe FF0000, let's say I make it like FF 0000. This is basically indicating red color in hexadecimal. But then if I, let's say, want to alter it and make it something like double F, or maybe 00 double F 00, then this is going to become as blue. So in your book you have multiple examples of this, but these are not to be memorized, not to be memorized. This is just to be just as an hint, so that you all are well aware that if you want to, let's say, know where a hexadecimal is used, so you should be aware that these line, these stuff where we basically write the code of a specific what do we call it, color, or a specific art, or a specific drawing, the color which is representing that one point or that one color, this is basically written in hexadecimal. So if you're ever given a number like this, you should be able to understand, and you should be able to judge that this is basically a hexadecimal value. Hexadecimal value. Apart from this, when discussing HTML color codes, it's also important that you have a general idea of what's HTML. So if you are ever going to explore the field of web development, you're going to be hearing the word HTML. So HTML basically stands for hypertext markup language. Markup language. So you might have heard the words Python, C++, Java, and all these programming languages, which are basically used to develop a specific program. So like every language has some specific usage. Just like that, HTML is one sort of markup language which is being used by programmers to build websites. Say, so if I have to program websites, I use HTML. So the purpose of HTML is to build, or you can also say program, websites. But one important point to note here is that your HTML is not a programming language. It is not a programming language. This is very important that you are aware that your HTML is not a programming language. It's basically a markup language, and there's a difference between them. I will explain that. Okay, so it is not a programming language. It's a markup language. Now, what's a markup language? So a markup language is a sort of language which, rather than following a strict syntax, basically makes use of tags. So when I say it's a markup language, this basically means that it is making use of tags, headers, and stuff like that. Now, this used to be tested beforehand, like in previous pre-2023 exam. This was something which were being tested at every point. So they used to tell you what's the difference between HTML and all that stuff. But now at this point, it's not explicitly asked, but just for your sake, you should be aware that this markup language is basically used in processing, defining, and doing the presentation of text. So we can also write that used for defining and presenting text. So if I want to, let's say, write a specific line or a specific sentence in red color, so the specific code which would be used to ensure that that line is represented in red color, that would be done through HTML. So HTML, इससे ज़्यादा आपको नहीं पता होना चाहिए. You should be just aware that HTML is basically a markup language which is basically used for defining and for like presenting your text. Or we can also say that it is also used for like processing your text. So processing could also be added up here. And it makes use of tags and then headers, which basically allows it to format the text. बस इसके बगैर आपको कुछ पता नहीं हो चाहता. This is just a short introduction into what HTML is. And HTML is basically the web software, not a software, is basically the markup language which programmers use to build or program websites. The important point here with respect to what we are learning right now is that the HTML color codes, which are basically used, so like if I'm writing these tags or headers while doing the specific coding, somewhere in between, I might use a hashtag 77AABB to indicate that whatever sentence I'm writing, like hello, let's say, this is for instance just an example, it should be written in this color. Okay, so this 77AABB is basically what's written in hexadecimal. So this is in hexadecimal format. So you should be aware of this. What among this HTML is within hexadecimal? So your HTML code is not a hexadecimal. This is not hexadecimal. The color codes used within the writing of a HTML specific website is basically a hexadecimal value. So this is an hexadecimal value. and we write these values when we either have to represent a specific color in a graphic software, or maybe while addressing some sort of where we want to build a website and we want to represent a specific thingy with a specific color. Say, so is this clear, everybody? Because this marks the end of the uses of hexadecimal. So we as computer science students should be aware of these four specific points where we can make use of HTML, and where we can make use of hexadecimal values. Say, so you should be just aware of where within these four sectors can a hexadecimal be used, and where why is it being used. So like in this case we are using it just because so that we can represent a lot of colors. अब यहाँ पे अगर मैं counting करूँ तो we all are aware that this 7 could be counted as like 4 bits separately. So if it can be counted as 4 bits separately, this means that if I see that 4 bits, every bit could have a specific denary, which means that I could have up to 15 possible combos in one specific bit, and this could get then multiplied, and you see we can have multiple sort of combinations. Because we can have multiple sort of combinations, this allows us to represent a larger range. So that's the reason why basically we are making use of hexadecimal values. And again, because we want to represent multiple shades, it's also easier for us to identify, rather than memorizing that 0110 would be representing red, or maybe 011010 might be representing a darker shade of red or something like that. So it's literally recommended that you go with this. And also I forgot many link nahi bheji thi in the group. Can anybody of you kindly just resend the meetings link in the group, so that if anybody is finding it, they can just quickly join in through that, even though I've been repeating that the link for these demo classes are the same. So if anybody could kindly re-forward it, it could be highly appreciated. All right, so we're done with this. Let's continue with the next part. So ab humne ye dekh liya, we have generally studied what the number systems are. Thank you so much, Inaya. And I guess Samraj is also typing, so thank you so much, Samraj. Appreciate it. All right, so at this point, we have studied what hexadecimal is, what's binary, what denary, what's the basic purpose of having them in our lives. Now, currently, we are going to be learning one concept, which is known as logical shifts. See? So at this point, this concept might not make sense to you, as if why are we studying? But it's just there in your course, and you should be aware of what this whole concept is, how it's implemented, and the main benefit or the purpose of understanding logical shifts would be something we are going to be addressing later on, inshallah. So even like once you get to A levels, and also in your university level, if you're planning on taking computer science, you're going to understand. I will send the notes, inshallah, tonight, okay, in the group. So aap wahan se dekh lena. So these logical shifts are basically used. And what's a logical shift? Logical shift pehle samajh lete hain. So if I have a specific binary value, let's say we have 1010 1100 1 2 3 4 5 6 7 8. Okay, I have this as an 8-bit binary. 8-bit binary. Now, if I tell you that, Samraj, can you please do one thing, that can you make every bit one towards left? So like if I'm saying that 10 students are currently standing in a line, can you make sure that every one student gets to one left to where they were actually standing? This is basically what we call as a logical shift. So we are basically shifting the bits to either left side or right side, depending upon what type of logical shift we have. So like we have one known as logical shift left, in which we are basically shifting all the bits towards the left side. And then we have a logical shift right, in which we are basically shifting all the bits towards right side. So now in this case, we are going to be firstly looking into logical shift left. And in your exam, by the way, they would be clearly mentioning it, but in some hardware questions later on, once you study chapter number 4.2, you're going to see that logical shift left is sometimes denoted as LSL, logical shift left. But in your exam, if you're writing, yes, coming to that point, Samraj, we're going to come to that point, don't worry. So logical shift left basically could be written as LSL. So if it comes in your exam as LSL, don't get worried. By the way, the examiner would clarify they don't write vague statements, but you should be aware that LSL usually is the mnemonic for logical shift left. Now, what's LSL? LSL basically means that if I have this specific binary, I'm just going to ensure that every bit is basically shifted one towards left, which means that this, if I make like the same slots, the same to same slots, I have a slot up here, then up here, then up here, then up here, one up here, one up here, one up here, and one up here. Starting from the most right hand side, this 0 is basically going to go to this side. So this is going to come up here. This 0 is going to go up here. This one is going to come up here. So we are basically shifting every bit one towards left. Oh, whole ज़्यादा ही कर दिया. This is going to come up here. This zero is going to come up here. This one is going to go up here. This zero is going to go up here. But now you're going to note that we are done with the available spaces, right? We are done. We don't have a space to accommodate this one. So where's this one going to go? We don't have space. Because we don't have a space, this one is going to go and we are going to ignore it. So it's just going to get lost. Ignore and lost. See? So it's gonna go and it's very like, okay, bro, we were standing at the edge of a big building and the teacher was not the teacher, maybe they were asking us to basically go move towards left side and we were moving and moving and the one who was literally at the boundary because he was at the top of the building and he was at the boundary, the moment he went one more towards the left side, he literally dropped off. So the same concept is being applied. Now in the line, we don't have that specific person. So he might have just went down onto the jumping castle or whatever. See? So we're just going to ignore that. At the top of the building, we now have only these slots. But now we're going to see that, sir, you tell me one thing, what will we be writing up here? So remember, if we perform a logical left shift and we have an empty slot, so remember, I told you guys in yesterday class too that if there is an empty thing, be a slot left, or if I have to, let's say, add special places or I have to fulfill a specific condition, I can literally just add useless zeros because zeros do not have any sort of values. So if I add a zero up here, it's going to make no difference because the only difference made in binary is through ones. So now what's going to happen? We've just basically shifted this whole 8-bit algorithm one towards left. Now, coming to why did we perform this? The purpose is that if I calculate the above original binary's denary value, let's calculate it. It's going to be 1, 2, 4, 8, 16, 32, 64, and 128. If I just count all those where we have a 1, it's going to come up as like an 8 plus 4 plus 32 plus 128. Now you guys could do it quickly because we don't have time. I'm just going to quickly go and do it through the calculator. So it's going to be 8 plus 4 plus 32 plus 128. So it's 172. And now if I calculate the equivalent value for the below shifted logical shift left value, it's going to be 64, 16, 8, and if I add them, and let's say, we assume that we have a larger capacity. In this case, we don't, but let's say, just to explain the purpose of why do we perform these logical shifts, the purpose is that let's say we had a larger bit register, so larger register, we would have a space up here too, right? So this one would have went up there, and now we're going to be basically adding this two into the calculation. So it would have been 256 plus 64 plus 16 plus 8. And now if I add these up, it's 256 plus 64 plus 16 plus 8, you're going to see that I get the answers as 344. And now the funny part is that 344 is the exact multiple of 172. So we found out that when you perform a logical shift towards the left-hand side, it's basically going to double your value. So the purpose of having a logical shift, as the question stated by Samraj, we have these logical shifts because if I want to double a value or maybe half a value, and I don't want to go through those longer methods. So what I can easily do is that I can literally just shift the bits towards left-hand side and it's going to double the value. So now if I go and do another logical shift towards left, if I make sure that this zero comes up here, this zero goes there, this zero goes there, one goes here, one goes here, zero, and go on, so on. Given that we have extra space at the end, let's say we have like a 16-bit register rather than a small 8-bit register. So this value is again going to get doubled. And so rather than 344, it's going to become a 688. So sometimes you might have seen that if I'm using a calculator and on the calculator, let's say I do 30 and I want to multiply it with 2. So I do multiply by 2. And the moment I press equals to, you see it's becoming 60. So rather than doing a longer calculation behind this, what computers can directly do is, yeah, okay, 30 ki binary is this. Let's just perform one logical shift towards the left-hand side. It's just going to shift those values towards left and just calculate the equivalent denary. And that would be the double of it. So the purpose of having logical shifts is that logical shift left basically results in the value being doubled. So it doubles the value. And just like the logical shift left, we also have the logical shift right, because I stated that we could either have a logical shift towards the left hand side or towards the right hand side. So in the right hand side, we have a, like, let's say, logical shift right, which could be then denoted by an LSR, right. LSR. Again, in your exam, they won't be using LSR directly, but you should be aware of it. Say so, it's better to stay safe rather than taking risks. So, a logical shift right now, what happens is that, let's say if I have a similar line, or perhaps let's come up with a newer one, 1 0 0 1 0 0 1 0 1 2 3 4 5 6 7 8. So in LSR, what happens is that we're basically having 8 slots: 1 2 3 4 5 6 7 8. Starting from here, this 0 is going to go towards right. So this 0 is going to come up here. This one is going to come up here. This 0 is going to come up here. Then this 0. Then this one is going to come up here. Again, 0, 0. And this one is going to come up here. Now, in this scenario, we see that we have this 0 coming out. And so the same example as the one we used up here, if we, because it's a right hand side and we know that this is the starting point, we cannot have this 0 accommodated in any possible way. And so this bit which has been shifted towards right, this is basically ignored. So we can say it's ignored or it's lost. Whereas now we're only dealing with this part, but we have one empty slot left at the most left hand side. Now what to do for that? We can add zeros on the left. Yes, exactly, Samraj. We're not adding a 0 up here. We're not adding a 0. We're going to ignore it because we cannot accommodate this scenario at all, because we can only add zeros to on the left hand side, because we cannot add any zeros at this side. Isko hum ignore kare. Yahan pe whatever this 0 bit, this is lost. So I'm like, okay, bro, you can leave. Tata, bye bye. No need to come back. So this person goes, and we do not consider this 0 anymore. But you see, we have a slot left at the most left hand side, which you all are aware that if we have a capacity left and we need to accommodate something in there, what is the procedure? We're going to be adding what? A 0. So we're going to be adding a 0 up here because 0 don't have any value. Now, if I have to calculate the denary of the original value, so the denary of the original, it's going to be what? So let's do it. 1 2 4 8 16 32 64 and 128. Let's add them up. So it's like 128 plus 16 plus 2. So it's like 130 and 146. So it's going to come up as 146. And I'm going to be calculating the denary of the logical shift right. Now, before even calculating it, I can tell you that this would be basically the half of the original value. So if I divide this by 2, I would be getting the denary of the logical shift right. Let's do it the other way around. So if I do it on calculator, if my logical shift is being done the right way, we should get an answer of 73. Okay, so we should get an answer of 73. So if I do it and I calculate this up here, wait, Samraj, I'm coming to your question. So it's going to be 64 plus 8 plus 1. So if I add them up, 64 plus 8 is basically 72, right? And 72 plus 1 is 73, which is 100% same to the one which I got up here. Hence proving that when I perform a logical shift towards the right hand side, this is basically going to half the actual value. Half the actual value. So, or I can say divide by 2. Say, now coming to the question stated by Samraj. Samraj is saying, sir, I'm talking about logical shift left. You added 0 on the right, but in the previous classes, you said we cannot add a 0 on the right. Yes, you're correct. But you see, basically what happened up here was that, let me explain it through one other example. In the logical shift left, we have basically a register. So we have a register like this, okay? And it, let's say, has 1, 2, 3, 4 and 5. Let's say we have 5 slots in it. Say we have this one register. Now I duplicate it, and this is the one register. Just kind of we need to perform the other thingies, like I have to shift it. So originally I had, let's say, 10101. Now if I want to perform a logical shift towards left, this means that this one is going to come up here. The 0 is going to go up here. This one is going to come up here, and this 0 is going to come up here, and this one is going to go and it's going to get ignored. But now the point which I was originally stating in the previous class, that was for the statement that we cannot include zeros up here. Now our starting point is this. In this scenario, you're going to see that our starting point is empty. You see, our starting point is empty. So in the original classes, the scenario was that basically we had a starting point which already was being filled up. So you cannot add a bit before the starting point. So we cannot add a zero up here. But definitely our starting point is empty up here. So I'm still going to say we cannot add zero up here, but we have this slot as empty. So I'm going to be putting a zero up here. So that is the point which basically I was trying to say, that in our previous classes, when I said that we cannot add a zero on the right hand side, it basically meant that we cannot have a bit on the right to the starting point. But in this scenario, we're not adding a bit on the right to the starting point. Basically, we are adding it into the slot where we have the starting point, which is being empty at this case, right? अब इस one को इधर ले आओ तो definitely this is going to stay empty. But we need to ensure that at least these 5 bits are being filled up. Now, how will I be doing that? So I need to fill this starting point with something, right? So to fill that, I'm just putting up a 0. I'm not bringing on a 0 on the right hand side. If I want, अब यहाँ पे हो सकता है कि let's say I have one extended place. Let's say we change the scenario a bit, and so I see that this one is going to come up here, and now I have one empty slot left. Again, I have empty slot, I can put up a 0, and if I want, I can also write 0 0 0 0. So I can write my answer as this: 0 1 0 1 0. It's not going to make any difference. But you see, I can add those zeros on the left hand side, but we cannot do it on the right hand side. Sir, what if we have to move it to two left shift? By the way, don't say LSL. Try to write logical left shift. सही है, तो वो पूरा लिखो. एग्जाम के अंदर LSL पे मार्क्स नहीं मिलेंगे if you guys write the key shortcut. See, now Inaya is saying, what if we do it twice? So Inaya, if we do it twice, it's just going to be 100% same. Let me recopy जहाँ से हमने छोड़ा था. So it's going to become, okay, no, class again. Oh, my bad. So it's just going to become this thing, and I'm going to repeat the same thing. So like this is maybe logical shift performed once, logical shift left x1, and now I have to reconduct logical shift x2. So it's just going to be that I would be reconducting the same procedure, but now on the original, not on the original, but the updated one. So this 0 is basically going to come up here. This one is going to go up here. This 0 is going to go up here, and this one is going to come up here. And this 0 again is going to be ignored. Unless we have a register where we can accommodate this. But again, now we have a 0 and we have the starting position as empty, right? I cannot add a 0 up here, but now because definitely my starting position of the same register, like it's the same thing. You have a shelf of books. Let's say we have these 5 shelves. This is a big shelf and we have 5 columns in it. And let's say you're shifting one book towards the left-hand side, done, and one book just falls off. Okay, no worries. But now you bring in a new book and you want to accommodate it. You have to fill the starting point, right? Because why do you want to go and build a new shelf if you already have a space? Now, if you have this as your wall start, if this part is your wall, you cannot put a book on the right side to this, right? You cannot even extend it. It's the same way if I say that I have in my room, this is my wall, and up here on the wall, I have a shelf. This shelf has basically 3 slots right now. And so if I basically shift one up here, this one goes up here, this one goes 0. And now if I want to extend it, definitely I can build the shelf and I can extend it like this. But you tell me, if I have the wall up here, is there a possibility that I go towards this side? No, that's not possible. Either I have to break the wall, which means that I have to basically break the logic set by the computer, or otherwise, if I basically shift it towards left-hand side and I see that one of the shelves most close to the wall is empty, I can fill it with maybe some slot or maybe with whatever book I have. So this was a pretty good question, but now is this clear behind why we why do we have a 0 on the starting point and why not? Say perfect. That's great to know. So we are basically done with this part. We understood how logical shift. Now, I have a question for you all. So if I originally have this binary, which is 1, 2, 4, 8, 16. So it's basically 21. The binary value of this is 21. So apologies for that, guys. होता रहता है यहाँ पे जरा, yeah, my bad. So never mind. There were some people and they got scared for no reason. All right. So if let's say we have a specific denary, and now I have to edit this video too, which I cannot. So never mind. Whoever is watching this video later on, apologies. I'm taking this class in my building lounge right now, and some people literally just got scared. Never mind. So I have a question for you all. If I have this binary value, and the denary for this binary is 21, okay? The denary for this value is 21. And now I ask you all to tell me one thing. If I perform a logical shift twice on it, twice, not once, twice. So one times and then again two. If I perform it twice, what's going to be the denary value at the end? What's going to be the denary value at the end, given that we do have a maximum capacity? So like these registers can extend, so like I can say that this one does not get ignored, we have extra slot up here, so it's going to increase and it can shift. Okay, 20, no, socho 5, no, Samraj ulta karo. 20, 80, 21. Guys, tell me one thing. If I have this as 21 and I perform a logical shift towards left once, it's going to become as what? Ramin, correct. If I perform once, it's going to become 42. But I said that I need the answer at the end, which means that I performed the logical shift twice, not once, twice. एक दफा मैंने कहा perfect Samraj. Yes, the answer is going to be 84. How? Basically, we have a 21 up here. We performed the logical shift once, which basically doubled the value. So at this point, we have the value as 42. And then again, when I perform the logical shift, it's going to become as 84. So it's basically getting multiplied by 2 and then again multiplied by 2. So the final answer is going to be 84. Just like that, in your exams, the question would be like this. They're going to tell you that you have a specific logical, this specific binary, and then they're going to be saying that, okay, bro, perform a logical shift on this towards left twice, and then you're going to be performing that twice. And once you're done with that, they're going to be saying what's the impact. So you're going to just say that if I did it twice, it's going to double the value or maybe multiply the value by 4. So in this scenario, if they ask you what's the impact, so impact ke andar I can say the value is multiplied by 4. The value got multiplied by 4. Got multiplied by 4. How 4? एक दफा मेरा हुआ multiply by 2 and then again multiply by 2. So the final answer this way is going to be 84. And just like that, if I tell you guys to do it like if this was 21 originally, or maybe if this was 20 originally, and I tell you that you need to perform a logical shift right twice, so this would have basically half the value 2 times. So it would have went from 20 to 10, and then 10 ka bhi half, okay, it would have went to basically 5, which would have been our answer if it was a logical shift towards the right hand side. सही. So ये आपको थोड़ा सा लॉजिकल शिफ्ट्स के बारे में पता होना चाहिए. एंड क्वेश्चन रिगार्डिंग दिस वुड बी लिटरली द सेम वे आई जस्ट answered. So inshallah, when we are doing the topical questions at the end of the chapter, you're going to see that we would be looking into these questions too, and asaani se ho jayega. You guys don't need to worry at all. Easy peasy sawal honge, don't worry. So the battery is running low. Just give me a minute, let me connect the charger. Till then, do you guys have any questions, or is this perfectly clear? Everybody quickly in the chat box, let me know. Guys, the question which Samraj asked, that was pretty good though. I really appreciate, and I would highly recommend that everybody of you ask such questions, because it helps with the concept building, right? So the more questions you ask, the better your concepts are going to be and the higher you're going to be performing. So if you do not focus on question asking, you won't do good. So yeah, perfect. So now if it's all clear for everybody, Ramin, is it clear? And Saifullah, is it also clear? आप लोग भी बता दो अपना input so that we can continue. Perfect. All right. So if we are done with that, Saifullah, do you have a question? Otherwise, we can continue. All right, seeing none, so let's continue. Ab dekho, we have studied everything till now. We have studied how I can write 20 in binary. So I studied how ulta ho gaya. So till this point, we have studied if I have 20, how can I represent 20 in binary? We saw that if I have 0110, how could I write this in denary? But we did not study one thing. What if I give you a question that, bro, 20 plus 30, but not in terms of denary, in terms of binary? If I ask you add 0110 plus 1100, what will be the final answer? So there is a proper procedure to this, and we're going to be following that. So what's happening here? We're basically adding two binary values. So we're going to be studying addition of binary values. Addition of binary values. So while studying addition, okay guys, आप लोगों ने तो आंसर्स बता दिया. I'm not sure though what's the answer going to be. वो हम देखते हैं. सही है. So while studying this concept, we're going to be first learning some rules. We need to first memorize those rules, and those rules are basically directly going to be applied onto our answers. Now, if I say that I have 0 1 1 0 and I'm adding 1 0 1 1 into it, so our answer. एक second. Okay, just guys give me a minute. एक second देना. All right, so we're just going to be learning those rules today and would be ending the class. And inshallah, in next class, we're going to be starting the whole chapter with proper practice. What are those rules? Definitely, we don't have 1, 2, 3, 4, 5, 6, 7, 8, 9. Neither I can figure out कि यार यहाँ पे कौन से 1 की बात हो रही है, 2 की बात हो रही है, 3 की बात हो रही है. For that reason, the computer scientists defined some specific rules. They were like, bro, if you're adding 0 and 1, your answer has to be 1. Okay, just like that, if I'm adding 1 and 0, the answer is again going to be 1. But if I'm adding 0 plus 0, the answer is going to be 0. And for instance, if I have a special case where I'm adding, let's say 0, sorry, not 0, maybe 1 and 1. So I'm adding 1 plus 1, the answer will again be 0 because we do not have a 2, right? But if I have a 0 up here, I would be including 1 carry. So plus 1 carry. It's the same carry which if I say that I'm adding 10 plus, let's say 19, and I'm doing this. So 9 plus, this is going to be, no, not like this. Let's do it the other way around. If I, let's say, want to do 13 plus 19. So 9 plus 3 is what? 12. So I cannot write 12 up here, right? So I'm going to be writing 2, and this is going to go as 1 carry. And so the same concept is being applied that if I'm adding 1 plus 1, so this 1 plus 1, if I have a binary number like this 1 plus 1 would be written as 0, and this 1 is going to go up here as carry, which means that I also should be aware of what to do if I have 3 binary values. So it's 100% going to stay the same, that if it's 0 plus 0 plus 1, it's going to be 1. If it's 1 plus 0, if it's 0 plus 1 plus 0, again it's going to be the same. If it's 1 plus 1 plus 0, then it's going to be this one. So main point है कि ये 4 rules आपको याद हो जाने चाहिए. And the final one, which is an exception, is that if you have 1 plus 1 plus 1, this is basically going to lead you to an answer of 1 plus 1 carry. And this can only be possible if I have, let's say, 1 being added with 1. Let's say I have a binary value like this, and 1 is being added with 1, and I have a carry 2. So in this case, it's basically 1 plus 1 plus 1. So the answer is going to be 1, and then a carry is going to come up here. Now let's do this short question, and within practice, you're going to memorize all these terms too. So you don't have to worry. It's going to be easy peasy once you memorize these rules, and these rules are going to be learned if you start practicing. See, so practice karte, let's do this one question. So we have 0 1 1 0 being added with 1 0 1 1. So I won't be converting them into denary, all that stuff. I can do that too. So I can basically convert this into denary, convert this into denary, add them, and then find the final binary again. But if I want to do it through the proper method, it's going to be that I would be following these rules. So 0 plus 1 according to these rules is what? It's basically this one, right? 0 plus 1 is this rule. So my answer needs to be 1. So I'll be writing 1 up here. Then the second part says that I have double 1. I have 1 1. So I'm basically adding 1 and 1. So 1 plus 1 is what? 1 plus 1 is basically a 0 and a carry. So I'll be writing a 0 up here, and this 1 is going to go up as a carry. Understand? You guys get it till this point? These rules and what I have done till 0 and 1. Is this clear? यहाँ तक समझ आ रही है या नहीं आ रही? तो let me know so that I can revise the rules. Because what we are doing up here right now is that we are just literally looking up to the rules. We're literally looking up to the rules, and we're just doing the calculation. Now we have a carry up here, and then we have a 1 and then a 0. So now we are basically dealing with 1 plus 1 plus 0. Which is just like this, 1 plus 1, and definitely you all know कि यार 0 के तो कोई फर्क पड़ना नहीं है. So 1 plus 1 plus 0. So 1 plus 1 is what? It's a 0 with 1 carry. Again, the same thing. So I'll be like, okay, 0 with 1 carry. And now what's going to happen? It's again 1 plus 1 with 0 with 1 carry. So this is going to come up as 0, and I get a 1 up here. And this one is basically going to be written as the same. 1 plus 0 is 1. So this one is going to come up here. But the problem was that originally I had only 4 bits. So on those 4 bits, I get 0001. But now where will this one go? This one does not have a place. He is told, bro, आपकी जगह नहीं है, आप चले जाओ. No, no, Inaya, you are correct. You are correct, Inaya. Where will this one be gone? So my answer is going to be 0001 because why? I do not have possible slot. So I can say that the register was, let's say, of 4 bits. Where can I include the fifth bit, which I get up here? Where will this one go? I don't have place for it, right? So a scenario where a fifth bit is being generated, or maybe if it was an 8 bit, if a 9 bit is generated, and we do not have a place to accommodate it, it is basically known as an overflow error. So an overflow error is basically when you do some sort of calculations and you add or maybe subtract or do whatever you're trying to do, and it basically results in an answer which the specific register could not store. So like I can say that you are basically adding 2 columns. So like let's say you have one library and you have the second library, and I'm say that you're storing them in this one larger library. So this might have 5 and this might have 4 books. But this library had like a capacity of only 8 books. So this one book, where will that be going? We don't have a place to accommodate it up here, right? So this one book is going to be out there. We cannot accommodate it, right? So either we could extend the library, which in this case is not possible. So this one book basically comes under the overflow error. So in exam, if a question asks you to add 2 values and then an overflow error like this occurs where a bit goes out and it cannot be accommodated, the question examiner would be saying that an error has occurred, name it. So you should be aware that we basically are talking about an overflow error. And an overflow error is occurred because it has the value which we have calculated, this value. It has basically occurred. This is a question which usually examiner tests. This occurs because the calculated value, because the calculated value is greater than the maximum capacity of the register. Maximum capacity of the register. So we basically, what we did was we calculated it and we saw that okay, books to hum 8 ही रख सकते थे, but now we have 9 books. Now where will that one book go? We cannot store it. We don't have space for it, bro. So that one book basically causes an overflow error. So you guys should be aware of it. In exam, they might tell you that, bro, what error occurred. First, in A part, they might tell you to add 2 binaries. जिनके लिए आपको ये rules follow करने. Now I know you might have not memorized it till this point. No need to worry, because in our next class we're going to be starting from addition of binary values and we're going to do multiple exam scenario questions. So I'm going to ensure that after like 3-4 scenarios, आप लोग को ये समझ आ जाए कि how are these rules being implemented. At this point, the important thing to note is that you understand the overflow error. So like if I'm adding 2 binary values and it results in a value which is greater than that bit which it could store. So like in register, so if I have a register which was of 4 capacity, but now I have 5 bits being formed, I cannot accommodate one of them, right? 4 to chalenge, but 1 kidhar gaya. That one basically causes an overflow error. So if in exam they ask you to name it, it's called as an overflow error. And why is it being caused? It's caused because the calculated value is basically greater than the maximum capacity of the register, which basically means, and it could also be seen in one other way, that if I have a 4-bit register, it can maximum store what? 1, 2, 4, 8. So if all of them are 1, 1, 1, 1, this means a 4-bit register can max store 15 in terms of denary. But if I add this and I count this, this is going to be 1, 2, 4, 8, 16, right? 16 plus 1 is 17. So I want to accommodate 17, but you know, the register can maximum store 15. Now how can I store 17 within 15? That's not possible, right? So basically it results in an overflow error. Now is overflow error clear to you guys? You guys don't need to worry about this addition of binary value wali rules, because we're going to be discussing them in next class, and inshallah udhar se hi discussion start hogi. For now, it's important that you get the overflow concept, logical shift concept, and the hexadecimal revision part. So everybody in the chat box, Ramin, Samraj, and everyone else, let me know, is this 100% clear, or do you have any sort of questions regarding it? If you do, just ask them. If not, to perfectly fine. That's great to know. That's great to know. So with that, our today's class was a bit short because I have to leave. I even told at the start I wasn't planning on taking the class, but still we had a pretty good class, and inshallah see you all on Monday. If you guys have registered for a course, you would have been added to a registered students group. If not, you guys should reach out to me and I would ask the TA to let you all in the group, inshallah. And from Monday onwards, I would be sharing a new link which would be only for the registered kiddos, which means all of those who have filled out the form. And see you guys in the class, inshallah. We will be opening up the group, inshallah, on Sunday. So we're going to be having a formal introduction on Sunday, and see you all on Monday in the next class. We're going to be starting off with proper practice of addition of binary values. I'm going to ensure कि आप लोग को याद करने की जरूरत ना पड़े. Inshallah, once you are done with these record classes, you're automatically at a stage कि यार sir, it's not that difficult. It's literally like adding one or zero. So easy peasy lemon squeezy. So with that, seeing that you guys don't have a question, it's 9:45 p.m. See you all inshallah in the next class. Take care. Allah Hafiz. Bye bye.